Alright, so in this second part I'm going to discuss how to build that monstrosity of a circuit using the last full adder design that we developed in the first part. Now, I did do two mistakes in the last part, which was that this dust in reality doesn't go there, and the carry can be outputted either from this torch or this torch, depending on what input is on. For example, if I leave this carry on and turn off one of these inputs, then in reality it's this torch that turns on, not this one. But if both inputs are on and the carry is on, the torch that turns on is the bottom one. So either one of these torches can supply a carry into the next full adder. Just to keep that in mind when you're building your full adders. Although in the context of this machinery that we got going here, I don't think it matters which of the torches is lit, because most of the time you're going to get a carry from the previous bit anyway, so this input will always have power. Although, I don't know if... let me test this actually. Can I get power from that top torch if I'm this distance away from it? Let's see. Yeah, I can. What about this one? Okay, so I can get input from either torches, so in the full design it doesn't really matter. It's just that the way I pulled the output from these two torches was not the correct way to do it. Alright, so now how do we build something like this using the full ladders that we learned how to build in the last part? Well, start off by building your first full ladder, which I have already constructed one for this purpose. I didn't put a carry input because for the moment we don't need to worry about the carry input. Now, how do we build another one of these so that they can operate as a single adder unit? Well, we start the same way. We place it just one block beside it, like directly beside it, starting off where this full adder ends. So let me extend that over here, and then we construct the full adder as normal. These are our inputs. We invert the input, redstone torch, raise up one block, redstone torch, block, redstone dust. That's the first OR gate, turning it into an XOR gate. Two torches, block, diagonal block, redstone dust on top. This one can get a little tight, but put a redstone torch underneath here. That's the first XOR gate. Now we build the next XOR. Actually, I could have left that block there. We build the next XOR gate. Our carry right here. Notice that this carry would be powered by either of these two torches. So, and again, put a block to avoid interference. Raise that up. Torch. So invert this top one. Alright. Raise the bottom one block. One more block. Redstone dust. Lamp. And now we convert this into a exclusive OR. Dust. Lamp. And now all that's left is to get the output carry of this other XOR gate. So we put diagonal blocks, one block here, and then one block up here, and I'm missing one block down here. Put a repeater running into this block, redstone dust on bottom, redstone torch, and redstone dust right here. So now we've effectively built a 2-bit adder. So if we add 1 plus 1 instead of using the carry to find the result, we're actually going to get the result from the two outputs of the full adders. So we get a 1 and a 0. If we add 2 plus 1, we get 3. So this is the concept used to build this kind of adder. So it doesn't matter how many full adders I add, it's always going to be the same. So the behavior of the circuit is the same. But we can add a couple more full adders just to get a more general sense of what we're doing. So switch off the inputs, and let's build at least 2 more so we can make a 4-bit adder. And then I'll explain how to make a subtractor from this. So, right there, we put our inputs, invert, input, and invert, redstone torch, raise 1 block, redstone torch, block, redstone, turn into an XOR, dust, redstone torch, feed this output into another exclusive OR, get the carry from the previous full adder, place a block to avoid interference, raise 1, invert, raise 1 block, block, and output. Now we convert this into a XOR, dust, torch, and now all that's left is to build the carry output, which we make a zigzag configuration here. Oh, I could have left that block there. Never mind. Repeater, dust, torch, torch, dust. Alright, and let's build 1 more. Oh, that's not what I meant to do. I destroyed one of my inputs. Okay, raise up 1 block. Place down our inputs. Invert the input. Redstone torch, raise 1 block. Redstone torch, block, dust, zigzag into another gate. But before we build the other gate, we turn this gate into an XOR. And next, let me finish this other gate first. So, get the carry, place a block here to avoid interference. If you're wondering why I'm using wool to build this, it's because, like most redstone builders, they use color coding to make their builds. So the most colorful block that you can find in Minecraft is wool. You have different colors of wool that you can use. That's basically it, just for color coding and to find out if you're building something and something doesn't work. It's much easier to find what doesn't work by using the color coding than building everything off of the same color. In this case, I'm using everything with white wool because I'm building one contraption. But if I were to add something onto it, I would probably choose a different colored wool, just to avoid confusion. Let's stone dust right here, and all that's left is to make this an XOR gate. So torch, torch, block, diagonal, dust, torch, and now the carry output. So block there, block directly above diagonal. Actually, I could have left that there. block here, block here, block here. Repeater, not facing that way, this way. Dust, torch, torch, dust. Alright, now we have a 4-bit adder. So we can add any combination of inputs. So right now we're adding 7 plus 1, which gives 8. If we continue adding, we can add up to 7 plus 7, which would give 15. We can verify this result, because this would be an 8 plus 4, that's 12, plus 2, that's 14. Why did I say 15? It's 14. If I add an 8 onto that, then that's 15, which we should get all 4 blocks lit up. Yep. Now if I add one more to this result, I would get a carry over here, which would be the 16. So this can only add up to 15. If we want to add more digits, then we need more full adders. In the case of the full adder that I built over here, which has 8 digits, it can sum up to 2 to the 8th power minus 1, which would be 255, I believe. 255, because 2 to the 8th power is 256. So the 8-bit adder can add up to 255. This simpler version can only add up to 15. Alright, so now how do we turn this into a subtractor, like the version I did before, or the 8-bit version? Well, I don't really have space to build the subtractor portion of the circuit without interfering with this, but essentially what you do is you add another exclusive OR to this input, where the input that you give as a carry would calculate the 2's complement of whatever your first input is. So if I switch this on, then whatever input I put in the top row, I'm going to get the 2's complement, which is nothing else than getting the negative of that value. So for example, if I wanted to subtract 2 minus 1, the result would be 1. If I subtract 2 minus 2, I would get 0. Now what happens if I subtract a number greater than my positive number, say 2 minus 3? Then the answer would be negative 1. But the way 2's complement works is that it inverts whatever the negative value is. So this result right here is actually negative 1. All I need to do is add 1 to it to get my correct result because of its 2 complement version. So this, even though it doesn't look like a negative 1, the machine actually interprets it as a negative 1. So just keep that in mind. Alright, so that's how to add the subtractor portion. Since I don't have enough space to actually build the subtractor, or, well, maybe I do. Might interfere a little bit with this XOR though. Let's see if I can actually pull it off. Okay. So if you see over here, I actually built up a little bit so that the bottom input would line up with the original input. So, and I don't think I need these blocks here. I don't know why I have them here now that I notice. So, let's see. I went up 1, 2, 3 blocks. Alright, let's try to do it. Even if I interfere with my other full adder. So 1, 2, and 3. 1, 2, and 3. 1, whoops, 2, 3. 1, 2, 3. Get the redstone dust up here. Probably should have built these one at a time, but Oh well. I get that there. And I need that there. There. Okay. 2 block spacing. Alright. So now we build this XOR just like before. This will be our new input. And I think that's it for the torches. Now I just need to convert this into an XOR. Alright, so that's the first one. Let's build out the second one, which I can abuse that these torches are occupying a block. And do this one. Redstone here. Torch there. Right, I think I already added the part for... Oh no, I didn't. I didn't add these torches. Alright, there we go. That's an XOR now. Okay. So I only need to build 2 more. Dust, torch. There. Okay, now we invert, and I think the only thing missing is these torches right here. Okay, I think we're good. Did I put the torch down here? No, I did not. Good thing I remembered. Alright, and the last one. Alright, I think now it is done. Okay, so the way the subtractor works is you have to 2's complement the top input, which that's the whole reason why we built this XOR on top here. Now, we also need to carry this input over to the first full adder's carry. So we're going to have to make a little bit of a ladder here to get up to where that input is. And also being mindful that you can only extend up to 16 blocks of redstone, we are going to start using some repeaters. So the way I built this in the other one is that I put a block coming out of one of the steps, placed a repeater going into the block, and then extended that up to where the regular inputs are. So this is our subtractor input. This is what tells the machine that we're going to 2's complement everything. Next, we place redstone here. Place a repeater here just in case, leading up to our machine up here, which I'm going to replace all these inputs with redstone repeaters. Now let's see if this actually powers on everything. Alright, looks like it does. Perfect, and it does its job. Okay, so now if I wanted to subtract, I should be able to. So if I subtract 2 minus 1, right now I'm doing 2 plus 1, which should give 3. Why is it giving 2? I might have a mistake in my circuitry. Let me verify. And yes, there is indeed a mistake in my circuitry because this XOR gate isn't outputting anything when it should, and that's because I forgot this torch, of course. There we go. So right now I'm adding both 2 and 1. If I want to subtract, I activate the subtractor. So now we get 2 minus 1, which would give 1. Looks like I made another mistake. Let's find it. This is powering on the carry, which is fine. Did I forget any torches up here? I don't think so. Let me just quickly verify how I built this. This is built the exact same way. That is strange. Let me verify that all my torches are well placed. That torch wasn't well placed. There we go. These mistakes, man, they cost you. But now our subtractor is working properly. So I did get the result of 2 minus 1, which equals 1. And I can test the same thing out with 2 minus 2, which should give 0. That's good. If I do, this is a 4, and let's do 7 down here. So 7 minus 4 should give 3. That is correct. Let's do 7 minus 5. That gives 2. 7 minus 7, 0. And then if I went overboard and did, let's actually do 15 minus 7, which should give a negative 8. We see that we do in fact have an 8 here. And let's see if I placed everything correctly. Yeah, 15 minus 7 would give a negative 8. Now this is the 2's complement of negative 8. So, yeah. Alright, so that's how the adder and subtractor works. Next thing I will be working on is registers, which would take the values of this adder and store them in memory using some, I'm probably going to be using static RAM for that, which is a type of memory that stores the value indefinitely until I think the clock changes or something like that. I need to review my RAM knowledge. So the next thing I will be working on is registers, and if I manage to complete a fully functional register, I will probably make another part to this. So hope you enjoyed watching how to build a adder, and I hope this inspires you to make your own redstone contraptions. If you have any questions or doubts, you can message me, and I'll be happy to reply to your questions, your doubts, or if you just wanted to learn more about what I'm talking about here, I will gladly help out any way I can. So, thank you.